Okay, method number 3 on how we can do sign numbers. The third method, it's also the most common. This is what you'll find in most CPUs on how they deal with integers, and that is called 2's complement. Now, the main goal of 2's complement is that let's try to remove that end around carry. That end around carry, while it's real easy for us to handle it, we want to try to get our operations down into one single uh, step. We don't want to have to worry about finding the last carry and bringing it all the way back around. So how does 2's complement work? Well, 2's complement is going to work in that we're going to take advantage of 1's complement and we're just going to make a little bit of a difference to it. We're going to start off with what the number is we want. We're going to do 1's complement to it. Then we're going to add 1. And at the end, we're going to get our result in what's called 2's complement form. All right, so let's do an example. Let's say I want it to represent positive 1. Okay, so positive 1, I'm going to want to change that into negative 1. How do I go about changing it? Okay, positive 1 is represented as 0, 0, 1. We're going to do 1's complement. 1's complement is I'm going to take each bit and do the negation. A 1 becomes a 0 becomes a 1, a 0 becomes a 1, a 0 becomes a 1, and then I'm going to add 1 to it. So I get a 1, 1, 1, and 1. And that is negative 1 in 2's complement form. So that's how we're going to go about doing it. Let's say, for example, I had something like 1, 1, 0, 0. Now I want to know what number is this. All I can tell is because the most significant bit is a 1, I know this is some negative number, negative x. Well, what is it? Okay, let's figure it out. Let's do 1's complement. A 0 becomes a 1, a 0 becomes a 1, a 1 becomes a 0, a 1 becomes a 0. So that's 1's complement. Let me add 1 to it. That's 1 plus 1 is 2. 1 plus 1 is 2. 1 and 0 is 1. So I got 0, 1, 0, 0. Okay, let's figure out what this number is. This number as a sign number ends up being, the weight is a 4. So we take that 4. We know that's the magnitude piece. With this negative, I can say I have a negative 4. So negative 4 is what 1, 1, 0, 0 is. So you can always try to figure it out. Okay, let's look at 0, because this is something that's going to be interesting for us. We do 1's complement of 0. A 0 becomes a 1, a 1, a 1, and a 1. I'm going to add a 1 to it. That's a 2, a 2, a 2, a 2. This carry, we're going to forget about the carry. I end up with 0, 0, 0, 0, which means that a positive 0 is the only value. With 1's complement, we had a positive 0 and a negative 0. Here, we're just going to have one form of 0. Okay, because we only have one type of 0, we're going to have a new range. So we have a new range. Then this new range for 2's complement is going to be, we have the same upper range, but we get one extra digit on the negative range. So for 4 bits, we end up having, our range can be -8 all the way to a +7. So we gained one extra digit. All right, so let's look at how we can do all of these values. So we're going to look at 4 bits. Here I have all the decimals of 0, +0 to +7. And we're going to figure out what our numbers are. Okay, we see that we only have one +0. We have no -0. So we're not going to do any operation on that. So let's take 1. First thing we're going to do for 1 is we're going to take 1's complement, which ends up being 1, a 1, 0. We're going to add a 1 to it. We add 1, we get 1, 1, 1, 1. So all 1s gives us the value -1. Okay, let's look at 2. 2, I'm going to do 1's complement. I get 1, 1, 0, 1. I'm going to add 1 to it. I would end up with 1, 1, 1, 0. Okay, what about 3? 3, we do 1's complement. I get 1, 1, 0, 0. I add a 1. That's going to leave me with 1, 1, 0, 1. All right, let's look at 4 now. 4, we do 1's complement. That's 1, 0, 1, 1. I'm going to add a 1 to that. That gives me a 0, a 1, and a 1. Okay, 5, do 1's complement. I get a 1, a 0, a 1, and a 0. I'm going to add a 1. I get 1, 0, 1, 1. All right, let's look at 6. 1's complement, 1, 0, 0, 1. I'm going to add a 1. That will give me 1, 0, 1, 0. All right, we're almost done. Let's look at 7. 7, 1's complement is 1, 0, 0, 0. I'm going to add a 1. I get 1, 0, 0, 1. Now, we said we're going to have an extra digit. We have an extra digit of -8. I got to figure out, how do I find the value for -8? I have no positive 8 to take 1's complement on with +1. So it ends up always being the extra option. So if we look, we would see that we would have one set of zeros and ones that is not being used. That ends up being 1, 0, 0, 0. No matter how many bits you go, let's say we went to 5 bits, the extra digit you're going to have will always be that 1, 0, 0, 0, 0. That first one and all zeros is always going to be your extra digit. All right, so let's do some math operation. That was the reason why we wanted to move to 2's complement, to get rid of this in around carry. So here we're going to do 2 plus 3. Okay, so I get 0 plus 1, that's 1. 1 plus 1 is 2. I get a 1, I get a 0. All right, let's see what number that is. What's 1, 0, 1, 0, 1? Let's go back to our little table here. 0, 1, 0, 1 shows up right here. Well, guess what that is? That's +5. Well, +5, that is what we wanted to solve for. All right, let's do another example. Let's do 2 plus a -3. So we have our digits set up. Let's add. 0 and 1 is 1. 1 and 0 is 1. 0 and 1 is 1. 0 and 1 is 1. So I get all ones. What did we want this result to be? We wanted this result to be -1. Let's see, what is 1, 1, 1? We scroll up. We see that all ones, guess what? That's a -1. That was our result. And again, we did this without having to do any type of in around carry. All right, let's do one more example. Let's do that. I wanted to do -2 plus a -3. I want my result to be -5. All right, so let's do some addition. 0 and 1 is 1. 1 and 0 is 1. 1 plus 1 is 2. 1 plus 1 plus 1 is 3. We're going to get an extra 1 as a carry. We're going to get rid of it. There is no extra in around carry. So let's look to see what number this ends up being. 1, 0, 1, 1. Let's see if that is -5. Let's go back to our table. 1, 0, 1, 1. Well, that's -5. And we did that without having to do anything with an end around carry. So we can see what ends up being a good benefit of this 2's complement. The last thing we have to do is overflow still exists. For 4 bits, 4 bits, we still had a range. Our range grew only in the negative by 1 spot. So we went from -8 all the way to a +7. I want to do 5 plus 5. I want to get a +10. This +10, it's outside the range. Well, because it's outside the range, we're going to see that when we add, we're not going to get a positive number. 1 plus 1 is 2. 1 plus 0 is 1. 1 plus 1 is 2. And then we end up with a 1. This is negative. Let's see what that is. 1, 0, 1, 0. 1, 0, 1, 0. That's -6. So we see that -6 is not equal to our +10. It's an overflow. We're outside the range. Remember, if you add 2 positive numbers, you have the conditions where you could have overflow. If your answer ends up being negative, you have overflow. If you add two negative numbers together, you could get into past -8. You would see that your number would be positive. You know, you had an overflow occur. So that's how we deal with our 3 different ways to do signed numbers. Now, integers is always done being 2's complement. When we end up doing floating point, think of it as like scientific notation. You're going to have some number times 2 to some exponent. That's usually done in sign magnitude. So you can see while we have 3 different options, different numbers end up using different methods of how to represent our sign digits.